Welcome to G Fun Facts Online, where we unpack the science that's shaping our future. Today, we're talking about memory, not the kind where you forget your keys, but the memory inside every single electronic device you own. For decades, we've been on a relentless quest to make our gadgets smaller, faster, and more powerful. But we're starting to hit a wall, a memory wall. What if I told you the solution isn't just a small step forward, but a quantum leap? Get ready to meet the dawn of a new memory era, ferroelectric memory. So what is this stuff? In short, it's a game changer. Your current phone or laptop likely uses DRAM, which is like a tiny bucket holding an electrical charge. The problem is, these buckets are leaky. They need constant power to stay full, which is why your data disappears when you shut down without saving. Then you have flash memory, like in an SSD or USB drive, which is great for long-term storage but can be slow to write to and wears out over time. Ferroelectric memory, or FeRAM, is the best of both worlds. It uses a special material with a natural, built-in electrical alignment, kind of like a tiny switchable magnet, but for electricity instead of magnetism. You can flip this alignment up or down with a tiny zap of power to represent a 1 or a 0. And here's the magic. Once you set it, it stays. No power needed. This makes it non-volatile, like flash, but with the speed of DRAM. It also uses way less power and has an almost unbelievable endurance. We're talking over 10 trillion read and write cycles. Your current SSD could only dream of that. The truly mind-boggling part is the scale we're working at. This is where subatomic engineering comes in. Scientists are now manipulating these materials at the picometer scale. A picometer is a trillionth of a meter. To put that in perspective, a single hydrogen atom is dozens of picometers across. We are literally engineering the building blocks of matter to create better memory. By using incredible techniques like electron holography, researchers can watch the electric fields around individual atoms, seeing exactly how they move and store information. It's like watching a dance of atoms in real time. This deep understanding has led to some massive breakthroughs. First, new materials. For a long time, FeRAM used materials that were difficult to build with the same tools we use for all our other computer chips. But recently, scientists discovered that a material called hafnium oxide, which is already used in modern processors, can be made ferroelectric. This is huge. It means we can integrate this supermemory directly into our existing manufacturing lines, making it cheaper and easier to get into the devices you use every day. Second, scientists are taking inspiration from nature. They studied a mineral called brown millerite, which has a bizarre and wonderful property. Essentially, its atomic layers are decoupled. You can shake one layer of atoms without disturbing the layer right next to it. By mimicking this, researchers think they can create memory cells that are tens of times smaller and faster than anything we have today. And third, they're building up. Just like we build skyscrapers to save space in a city, engineers are designing 3D architectures for FeRAM, stacking memory cells vertically. This will allow them to compete with the massive storage density of flash memory, giving us devices that are not just fast, but can hold enormous amounts of data. So what does this mean for you? The applications are transformative. For high-performance computing and AI, FeRAM could help break the memory wall bottleneck, leading to much faster and smarter systems. For space exploration, its natural resistance to radiation makes it perfect for satellites and spacecraft navigating harsh environments. For the Internet of Things, its low power consumption means your smart devices could run for much longer on a single battery charge. And for everyone, it means more reliable, more secure, and more efficient technology, from our cars to our data centers. This isn't science fiction. From university labs to commercial production, this technology is here. The future of memory isn't just about storing more, it's about storing smarter. And the era of ferroelectric memory is not on the horizon, it's dawning now. Thanks for tuning in to G Fun Facts Online.